Hi, good morning to all. Today we are going to study in detail about the applications of complexes. That is another important topic from the chapter coordinations, complexes and protein bindings. So we have discussed about what do you mean by complexes, its definitions, and what are the various intermolecular forces involved between the formation of complexes, that is A and B leads to the formation of complexes C. And now coming to in detail about its applications of complexes. So these are the learning objectives. So we are going to understand the importance of complexes and its role in drug delivery and therapy. And also we are going to appreciate the biological and pharmaceutical role of complexes. Now we are going to study each application of complexes in details. So first one, physical state. So physical state, you know that the matter exists mainly in three forms. One is solid form, another one is liquid form, another one is gaseous state. So these are the mainly main three physical states. So convert liquid substance into solid complexes. We know that we can easily convert solid into liquid, but there is a reverse transformations convert liquid substances into solid complexes. So nitroglycerin can be transformed into its crystalline inclusion complexes by forming complexes with beta cyclodextrins. I already told you that the betas are out of three forms, alpha, beta and gamma. Beta cyclodextrin is the most important one while forming complexes with the drug molecules. So mainly they form inclusion complexes. We also call it as occlusion complexes. So out of all the three forms, beta cyclodextrin forms important inclusion complexes. So nitroglycerin can be transformed into its crystalline inclusion complexes by forming complexes with beta cyclodextrins. Now the unpleasant nature of iodine is due to its volatile nature of the iodines. So unpleasant state is due to its volatile nature that can be overcome by forming complexes with polyvinyl pyrrolidine. That is PVP stands for the polyvinyl pyrrolidine. So the volatile nature or the unpleasant nature of unpleasant odor of iodine can be minimized or can be overcome by forming complexes with polyvinyl pyrrolidines. And solid state stability, the vitamin A and D, the solid state stability of vitamin A and D can be significantly enhanced by forming complexes with beta cyclodextrins. Next one, the chemical stability. The chemical stability of benzocaine can be significantly enhanced by forming complexes with caffeine. So here the caffeine is act as a complexing agents. So the rate of hydrolysis of benzocaine can be prevented by forming complexes with caffeines. So that the chemical stability of benzocaine can be significantly enhanced. Next one, the solubility of another important drug, that is para-aminobenzoic acid, can be significantly enhanced by forming complexes with caffeine. So here, remember one thing, the solubility of para-aminobenzoic acid can be significantly enhanced by caffeine only at low concentrations. So here, the caffeine acts as a complexing agent and the solubility of caffeine will improve the coffee the sorry the para-aminobenzoic acid solubility can be increased by forming complexes with caffeine only at low concentrations. Next application is the bioavailability. What do you mean by bioavailability? Bioavailability is nothing but the rate and extent of drug that reaches into the systemic circulations from the given dosage forms. So tetracycline is an antibiotic drug. So it forms a complexes with calcium, magnesium and aluminium, so that that formed complexes reduces the absorption of tetracyclines. So that's why while taking antibiotic like tetracyclines, we have to minimize the usage of milk. So because milk contains calciums, it form complexes with tetracyclines, and in terms it will reduce the absorptions. If absorption of tetracycline is reduced, its bioavailability also significantly decreased by complex formations. And indomethacin and barbiturate, that is a drug that form a complexes with beta cyclodextrins. Their absorption and bioavailability can be significantly enhanced by forming complexes with beta cyclodextrins. So these are the two classes of the drugs, indomethacin and barbiturates. Their solubility can be enhanced by forming complexes with beta cyclodextrins. Another one, the anti-ulcerogenic property of indomethacin. Indomethacin is a class of drug that causes ulcers. So the ulcerogenic effect of indomethacin can be significantly prevented by forming complexes with beta cyclodextrins. So the toxicity we can call it as reduced toxicity of indomethacin can be achieved by forming complexes with beta cyclodextrins. Next application is it can act as an antidote for metal poisonings. So the metals like arsenic, mercury, and antimony, and these are all the metals that form complexes with dimercaprol can act as an antidote. We can antidote means it act against poisons. So the arsenic, mercury, antimony poisoning can be prevented by using an antidote like dimercaprol. So once dimercaprol is added, it forms complexes with the metals like arsenic, mercury, and antimony. So the toxicity caused by this metal can be significantly reduced by forming complexes with dimercaprol. Another name of dimercaprol is British anti-Leucid. We call it as BAL, B-A-L. Okay, so British anti-Leucid and dimercaprol is the complexing agent for form a complexes with metals like arsenic, mercury, and antimony. It is the next applications. Another one is coming to the therapeutic actions. So the anti-malarial action of 8-hydroxyquinoline. 8-hydroxyquinoline is an anti-malarial drug. Its anti-malarial action can be enhanced by forming complexes with ions, so that increased penetration of 8-hydroxyquinoline through the malarial parasites cell wall is possible, and we can achieve increased anti-malarial actions. So 8-hydroxyquinoline forming complexes with iron. Okay, another one is para-amino salicylate that is act as an antibacterial agent. So the it can act as an anti-TB agent, the anti-tuberculosis drugs. So the para-amino salicylic acids is converted from a complexes with copper ion that become converted into cupric chelates. So the anti-tubercular activity of para-amino salicylic acid can be significantly enhanced by forming complexes with copper ions. Another ones, so importance complexes is that is available, and one is cisplatin. Cisplatin, we can see that there are two chlorine atoms and two ammonia atom, and central metal atom is platinum. So cisplatin, it is a potential anti-cancer agents. So cisplatin is also an example of complex formations. Another one is another example is cisplatins. Cisplatins also an example of complex formations. Similarly, one more class of compound is known as povidone. Povidone is also an example of complex formation between polyvinyl pyrrolidine and iodine. So these are some of the examples of complex forming agents like polyvinyl pyrrolidine form a complexes with iodine that we call it as povidone iodine. Another one is dichloro diamino platinum 2, that is cisplatin. Cisplatin is an anti-cancer drugs. So these are some of the important references for this particular topic. So you can refer the textbook of Physical Pharmaceutics by C.V.S. Subramaniam. Another one is Martin's Physical Pharmacy and Pharmaceutical Sciences. So these are the two textbooks will really help you to understanding the sessions in detailed way. So thank you for your active listenings. Thank you all.